Okay, we're on. Okay guys, today we are going to learn about concavity. Now, concavity is actually kind of the curviness of the function. And one thing I want to show you, and just don't write for a moment. Just, yeah, pencils down, just take a look for a moment. All right. This function, does anyone just remember, is this concave up or concave down?
Concave up.
This
Like
is concave up like a cup, right? Okay. Now I want you to notice this function, the function is increasing, but that has nothing to do with it being concave up. I could actually be decreasing and concave up, right? So the increasing and decreasing has nothing to do with the concavity. Here's how concavity is determined. The slopes of this function start out low and get higher, right? When the slopes of the function are increasing, the function is considered concave up. Now, that's harder to see with a decreasing function because it looks like the slopes are decreasing, right? But the problem is, or the difference is, that these slopes are all positive. These slopes are all negative. So where this slope might be negative 100, this slope might only be negative 1/2. So technically, mathematically, they're still increasing. Does that make sense? So whenever slopes are increasing, the function is concave up. All right? When slopes are decreasing, then the function is concave down, like a frown. Now, what determines slope?
Derivative.
The derivative, right? Okay, so the derivative is the slope. The slopes are increasing, which means the derivative is increasing. Now, yesterday we learned that when a function is increasing, its derivative is positive, right? So when the derivative is increasing, its derivative is positive. So if we want to know when the first derivative is increasing, that's when the second derivative is positive. So if the first derivative is increasing, the second derivative is positive, which means the function is concave up. Whoa. All that being said is to get you to determine the concavity of the function. So we're going to write a couple statements, and we're going to draw some pictures, and then we're going to get into the actual problems. So
You can take a
first,
picture of my notes if you want.
if f double prime is positive,
Yeah. Sure.
Should we start writing this down?
yes, now write. Now write. If f double prime is positive, this implies that f prime is increasing this is kind of bad math, but we're going to do it anyway, which also implies that f is concave up. So all three of these imply the others. If f is concave up, that means f prime is increasing, that means f double prime is positive, and vice versa. You do them in any order. They're all true, okay? If f double prime is less than 0, this implies that f prime is decreasing, which implies that f is concave down. Now, I didn't give this to first period, I'll give this to them later, but I kind of like to organize this a little bit in a chart.
Oh.
F prime, f double prime. So here's what I like to note. F prime is increasing, or f is increasing when f prime is positive. F is decreasing when f prime is negative. is concave up, and I use this little symbol for concave up like a cup. F is concave up when F prime is increasing and F double prime is positive. F is concave down like a frown when F prime is decreasing and F double prime is negative. This is how F and F prime and F double prime all relate to each other. Yes?
So if it's a linear function, does f double prime not
Equals
exist?
0. Yes.
Equals 0.
If it's a linear function, your F double prime will be 0. Just think about the second derivative, right? Right? So there is no concavity because it's flat.
Smart.
Right? Okay, good. Now, quick pictures. Okay, 4 quick pictures. This function is increasing and concave up, which means F prime is positive and F double prime is positive, right? Every single curve in the world is one of these 4 things all connected. It's all, these 4 shapes, you can take any graph on Earth with these 4 shapes and connect them. Except like if it's flat, right? Any curves. This curve is decreasing, but it's still concave up. Which means our F prime is negative, but our F double prime is positive. Do you understand what I'm saying?
I don't get the whole like why F prime be positive
F prime isn't. F prime is
now.
negative.
I mean F double prime.
Because it's concave up.
So
Up
like
like a cup.
every time it's concave up, it's going to be F double prime is positive.
Absolutely. 100%.
If it's decreasing, then F prime is going to be negative.
Yes.
And F, okay, gotcha.
Yeah. Okay. F prime determines increasing or decreasing. F double prime determines concavity. Okay? This one, is this function increasing or decreasing? This function's increasing, but it's concave down like a frown. So that means our F prime is positive, our F double prime is negative. This function is decreasing, concave down, F prime is negative, and F double prime is negative. All right. Does that make sense?
Yeah.
Awesome. All right, so for our first example, we're going to determine the, first we gotta do our test. I gotta write down your steps. All right, there is no name for a test for concavity, so I just call it the concavity test.
Sounds like a good name.
All right, thank you. It took a long time to come up with, but concavity test.
All 2 seconds.
Yep. The test for concavity. Number 1, you're gonna find F double prime and find, where F double prime equals 0 or is undefined. So essentially you're finding your critical values for F double prime. Right, so just like what we did yesterday for F prime, now you're doing it for F double prime.
So you make a sign like.
Ooh, step 2,
Make a sign line.
make a sign line.
You should make a rap video.
I was just thinking that, sounds like make a sign line, make
I'll
a sign
produce it.
line. All right,
Great minds think alike.
okay.
Yeah, that's C from Step
All
Brothers.
right. All right.
Deadliest catch without the
Step
crabs.
3,
Look like crab
write your
crabs.
answers with your because statements. And there are 3 of them today.
3.
3.
These are my least favorite statements ever.
They take forever to write. Cramps in my hand.
Yeah, seriously.
There's
I'm
less today than there were
I'm
yesterday.
gonna get like arthritis.
Arthritis?
Isn't that a thing? Arthritis?
Arthritis.
Arthritis is totally a thing.
Arthritis, that's a good word.
What is it?
Okay.
Like a disease.
Arteritis? No, it's definitely arthritis.
Anyway, when I write concave up, I
You guys-
allow you to use the symbol, just to save, so you don't have to actually write out the words concave up, right? So F is concave up, you're concave up on an interval. A to B, always open, because F double prime is greater than 0. Right? Next, F is concave down on some interval because F double prime is less than 0. Now, yesterday where the function changed from increasing to decreasing or decreasing to increasing, we called those relative maxes and mins. Today we're going to talk about where the concavity changes. I'm changing from concave up to concave down or concave down to concave up. These points have one name. Doesn't matter if it's up to down or down to up. Anyone know what these points are called?
Inflection.
Ooh, someone said it.
Inflection.
Points, these are points of inflection. All right? Okay, where the concavity changes. So we would say a point of inflection occurs, so I just do POI, point.
Sounds French.
A point of inflection occurs at the ordered pair. Points of inflection are points, right? Ordered pairs, points, at XY because. Now here's the thing I want you to be very careful about. Do not say that F prime changes from positive to negative or negative to positive because it doesn't matter. So all you have to say is because F double prime changes sign. You can use that one because statement for all of your points of inflection.
Sweet.
All right? Okay, here we go. First example.
3 more because statements left.
2 more. Just 2 more because statements left, and those aren't until next week.
I thought you said there were 9.
There are. We've learned these are 7.
Oh, maybe I should go back to like 3rd grade and learn how to add.
There.
Maybe that was your first problem.
That's when you learn how to add in 3rd grade.
No, you don't. That's when you
That's
learn
when you learn to tell
timetables.
time.
I learned to add in 3rd grade.
You learn to add like first.
No, you don't.
You learn your timetable in 3rd grade, I'm pretty sure.
Yeah. Oh, 5th grade.
Nah, you're behind.
I did my timetables in 4th grade. I don't know what you guys
Miss Feathers like
I did mine in 3rd.
I remember like you still have to add them in kindergarten.
You don't add in kindergarten. That's way too advanced.
Yeah, I
You
don't know
don't
about
like deal with
kindergarten.
numbers. You deal with like concepts. Like,
Okay, quiet down,
They didn't even
please.
care about
Shh. We're going to determine the concavity and the points of inflection for f of x equals negative 2x to the 5th plus 5/3 x cubed. So, first thing we have to find is f prime. I'm going to walk you through this
What is-
just for
why is it
time's sake.
X?
I'm sorry?
Points.
Oh, points of inflection.
You just run out of space, or is that actually how it's supposed to be? Written?
That is certainly not how it's supposed to be, that's how I write it.
Alright.
You could
you
put
get that
point of
count?
inflections, but that would be grammatically wrong.
Gotcha.
Yeah.
Alright, we're gonna have to take a derivative, I assume.
Yes, go ahead, did you take it already?
No.
I'm still writing it down.
Oh, I'm sorry.
I don't know what you think I look like.
Alright, so negative 10 to the 4th, x to the 4th, plus 5x to the 2nd,
Very good.
plus 0,
Nope.
Okay,
Bring
yes.
that negative.
Yep.
plus another 0, minus 3 zeros.
Alright, do we do anything with the first derivative for concavity? No, so everybody go ahead and find that second derivative.
That's
D2y
negative
over
40x
3x.
cubed plus 5. plus 10x.
All
I'm trying
right.
to trick you guys out.
Negative 40 x to the third plus 10x. We need to find where this is either 0 or undefined. Is it ever undefined?
No.
No. So we're just going to find where it's 0. I'm going to factor a negative 10x out. I like to have a positive leading coefficient. So I'm going to have negative 10 comes out, so I'm going to be left with 4x squared minus 1. Watch those negatives.
So it's going to be 0 is one of the x
So
values.
x is equal to 0. For
And
here, we get x squared as a fourth
Square root of 1/4.
So what are we?
plus or minus a half.
Plus 1/2 minus 1.
Okay? What do we do next?
Sine line.
Sine line. So we have, this is for f double prime, right? Negative a half, 0, and a half. We're plugging our numbers into f double prime. So if I pick negative 100,
you do negative 1.
I am positive on the inside, or outside, and I'm positive on the inside. So I am positive. Or I could go over here too. All right, this is tricky. At negative a fourth or negative a tenth, right?
Plug that in.
This is still positive, because negative times a negative, right? But in here, I get 4 1/100ths minus 1, it's going to be negative. Does that make sense?
Yeah.
So I'd have a positive times a negative, I'm negative. If I pick positive a fourth, I end up with a negative times a negative, so I'm positive.
Oh, snap.
And if I pick positive 100, I have a negative times a positive, I'm negative. Don't put arrows under these, this isn't determining increasing, decreasing. This is determining concave up or concave down. So you can put little concavity symbols.
Awesome.
Up like a cup, down like a...
All right, here's our answers. F, not F prime, not F double prime. F is concave up on what interval or intervals?
Negative infinity to negative 1/2 union 0 to 1/2.
Negative infinity to negative 1/2 union 0 to 1/2. Why? Because why?
Double prime.
F double prime is greater than 0.
F double prime is greater than 0.
I already wrote that down.
F is concave down on what intervals?
5-day weekend down.
It's so far away. Oh, on negative 1/2 to 0, union 1/2 to positive infinity.
Beautiful.
This is 5-day
Because
Yeah,
f double prime is smaller than 0.
Yes, less than 0.
Oh,
All
then
right.
one more.
Points of inflection occur at 3 places. Negative a half, comma something, 0 comma something, and a half comma something, because f double prime changes sign. Where do I find the y values for my points of inflection? Original function, and I'm just going to tell you the answers. Negative 0.146, 0, 0, and positive 0.146. All right, good. We still have 5 full minutes left to learn the second derivative test.
Really?
Yep,
That's not it.
Wait, what was that?
that was the concavity test.
That entire thing just to test concav.
That's right.
It would be on the quiz Friday.
Okay. The second derivative test is not a test for concavity. It's actually a test for relative extrema.
Will this all fit on one piece of paper?
No.
Not even-
This is an alternate method for finding relative extrema. So the first derivative test is almost like, it's not like it's a test test for the first, with the first derivative, it's the first derivative test for relative extrema. The second derivative test is like the second derivative test for relative extrema. Does that make sense? Now, the first derivative test involves the first derivative, and the second derivative test involves the second derivative, so you can think of it however you want.
So can we use either one?
There are problems that can be written to force you to use the second derivative test, but I will tell you that the second derivative test doesn't always work, and the first derivative test always works unless you're forced to use second derivative test. We can write problems to force you to use either one, right?
How can you tell?
Because we can.
But how can you tell
Those are
which
math.
to use?
No one's going to tell you which one to use. You can use whichever one you want,
No.
but there will be times, if you can make a sign line, you're going to do first derivative test. If you can't, you would do second derivative test.
Gotcha.
Okay? So here's the thing. Second derivative test, you're going to start by finding f prime and find where f prime equals 0. Second derivative test does not work when the first derivative is undefined. It only works when the first derivative is 0. If second derivative test doesn't work, you have to go back and do first derivative test. Alright, step 2. You're going to find f double prime.
So if there's an undefined value, then
You have to do first derivative. You're making a sign. You're back in sign line world.
So it's sort of like L'Hopital,
No. It's just an alternate method for finding relative extrema that sometimes works and sometimes doesn't. Alright. Step 3. You're going to plug the zeros of f prime into f double prime. If the answer is positive, this implies that you have a relative min at that value of x. If the answer is negative, this implies that you have a relative max at that value of x. Now, everything is easier with a picture. So I'm going to give you a visual of why in just a moment. And then if we have 30 seconds, we'll do an example.
30 seconds for example.
Yep. Okay, here's the thing. If the second derivative is positive when the first derivative is 0, that means the function is concave up, but the slope is 0. Which means we are at the bottom of a hill and we're at a min. Concave up function with a horizontal tangent, bottom, min. If the second derivative is negative, we're concave down. When the first derivative is 0, so we have a concave down function, horizontal tangent, we're at the top, we're at a max.
Wait, so is that line or that is that line equivalent to the second derivative?
No, this is all just a drawing of the function. So
Okay.
the function is concave down, that would be when the second derivative is negative. And if the first derivative is 0, meaning the tangent line is horizontal, where is that point? That point would be at the top.
Okay.
Okay? That's why you have a relative max there. Now, in 2 seconds, the bell is probably going to ring, but I'm going to do a 2-second example for this.
I don't believe in 2 seconds.
So we're going to find the relative extrema for f of x equals x cubed minus 4x squared minus 3x. Here we go. F prime. 3x squared minus 8x minus 3. Bam, 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 bam. 3x and x and 3 and 1 and minus and plus. X is negative a third or 3. F double prime, 6x minus 8. F double prime of negative a third you plug negative a third in, you get negative 2 minus 8, it's negative. So we have a rel max at x equals negative a third. Because the second derivative, the first derivative was 0, second derivative was
Do you
negative.
have to write the both coordinates or just the x value?
Well, you should write the whole ordered pair. And by the way, if it's a because statement, you would say because f prime of negative a third equals 0, and f double prime of negative a third is less than 0. Technically, we have to learn 11 because
I
statements,
probably,
right?
I probably put the y value too.
You should, but I don't have time for that right now.
She doesn't.
F double prime.
Nonsense.
Ain't got time for that right now. Okay. F
Ain't
prime,
nobody got
F double prime of 3, that's 18 minus 8, that's positive. So we have a rel min at x equals 3, because f prime of 3 equals 0, and f double prime of 3 is greater than 0. Woo, and there's the bell. All right, so do your best on this. Focus on concavity. Second derivative